Okay, sorry. Tell me what substitution is again. So substitution in real life is replacing something. Now, can you replace something with anything? No, it has to be something equal, right? You can't mess something up and then put something else in its place. Like, if there's not a history teacher here, I'm the last person you'd want to replace with that person because I know nothing. Okay? I would never replace a history teacher. Another history teacher would replace a history teacher, right? So it has to be equivalent. So knowing that, our first step is always pick a letter, X or Y, whose coefficient is most positive 1. Okay? It could also be negative 1, but we prefer positive 1. Okay? So where in these two equations, which letter has a coefficient of 1? The first equation, what letter? X. Okay, so knowing that, we have this x being 1, so we need to solve for x. So I'm going to take that equation, and I'm going to solve for x. So how would I get x by itself here? Add y to both sides, and I get x equals negative 7 plus y. Now I'm going to take the equation that I did not use, that second equation we did not use, right? And I'm going to write it down. Well, if I know x equals this, can't I replace x with this by substituting that in? Yes. So I'm going to get 2, and instead of x, I'm going to put negative 7 plus y minus y equals negative 9. So I substituted it in because if x equals that, then we can replace it. Now, a good quick check is after you substitute, you should have only one letter left. See how I only have 2 y's? It's one letter, okay? I know it's in 2 different places, but it's the same letter, okay? I no longer have an x and a y that I cannot combine. So now we solve for y. So what would I do first to solve for y? We're going to distribute. What's 2 times negative 7?
Negative 14.
And what's 2 times y?
2y.
I'm going to bring down my minus y equals negative 9. Now what? We're going to combine our like terms. What's 2y minus y? Just positive y. I'm going to bring down my minus 14 equals negative 9. Last step. Add 14 because we want to get the y by itself. So we get y equals 5. So we substituted it in and we solved for the variable and we got y is 5. So I want you to remember though, the solution to a system is an x comma y point. So we're only halfway there, right? So now we take the original equation that we messed with. The x minus y equals negative 7. This step is kind of coming down here. And we are going to plug in, if we know y equals 5, what did I just do? Why did I put a 7 there? Sorry, y'all. Okay, we're going to plug in y is 5. So x minus 5 equals negative 7. Well, how do I solve this for x? Add 5 to both sides, and I get x equals negative 2. So my final solution is x comma y, so negative 2 comma 5. Now, who can tell me what type of kind of system this is? Who remembers? The KOS, kind of system. Yes, you're exactly right. It's independent and consistent. So if you want to write I and C, that's fine. I just wrote it out just to remind you what those stand for. Okay? Remember, independent because it has one solution, consistent because it has a solution. Okay?
Why didn't you replace the x with the y?
Because y equals 5, not x equals 5.
Right, and x equals negative 7 plus 1. So we're going to put that?
Well, you don't need to because it got x by itself, right? So if we wanted to check our work, you can come up here to our originals. We know that our answer is -2, 5. This is my x, this is my y. So I can do x, which is -2, minus y, which is 5. Might help if I turn it on. And does that equal -7? Yes. So then I could also check it on this one, because remember, it has to work on both of them, not just one of them. And it also works. So that is my solution, and I just proved it. Okay. Any questions with that? So let's look at these two. Okay, so on number 2, what is our letter that has a variable of +1? +1. Where is our letter, not that has a variable, sorry, a coefficient of +1? The y, which y? First equation or second equation? The second one. See how this y is a positive y with no number? That's what we want. See, these both have a 1 as our coefficient, but they're a -1.
So they can't be used?
They could, but it's going to be more work.
So it'd be better to find one that just is 1, and if there is
yes.
one, you go up to then the
Yes.
one.
So we are going to subtract 2x from both sides. And now we have y equals -3 minus 2x. Now we have a coefficient, a variable alone. Okay, so knowing that, we take our equation that we did not mess with on the left side, and on the right side we put the equation, the original equation that we did mess with. It's just a negative. As long as you get that variable alone and positive, no. Some just give you more work. If you, like, you technically could have picked this -x, and you would have added y to both sides, and then you would have had to divide everything by -1 to get that negative to go away. The reason we picked this one is because all we had to do was one step. Does that make sense? Okay, so now we know y equals this, so we're going to replace y by substituting that in. So I get -x minus my y, which equals -3 minus 2x equals 3. Now I only have x's left, so I substituted correctly. And how do I solve this for x? Distribute what? The negative only. Whatever's touching the parentheses is what we distribute. So we're going to just distribute the negative. So bring down that -x. 2 negatives makes a positive. So this ends up being +3. Another 2 negatives makes a positive, so plus 2x equals 3. Okay. Now what? We can combine our like terms, which are these two, and that gives me, what's -x plus 2x? It's just 1x or just x. I'm going to bring down that +3 equals 3. Now what? Subtract 3 from both sides. And I get x equals 0. So I'm halfway to my solution. I know my solution is going to be an x comma y. So I know that x is 0.
How do you know it's going to be an x comma y?
Because solutions to a system is the point where they touch, and a point is x comma y. Okay, so now that I know x is 0, I'm going to replace this x with 0. So I get 2 times 0 plus y equals -3. What's anything times 0? So this cancels, and we get y equals -3. What kind of solution is this? Independent and consistent. Okay, so again, we can check our work. by literally just typing it in. So negative x is 0 minus y is negative 3 equals positive 3. It worked. And then 2 times x is 0 plus y, which is negative 3, should equal negative 3. Did it work?
Yes.
So that is our solution. Checking your work, y'all, is too easy not to. Don't even have to do it on paper, just do it in your calculator. No. Huh? Then you made a mistake somewhere. Huh? Well, I'll look at it with you in a minute, but it's negative 3, not positive 3. And it has to work in both equations, not just one of them. Okay, let's look at example number 3. What do we like about this one right away? Doesn't it already have a letter by itself?
Yes.
Yeah, so cool. We don't have to do anything.
We just have to go to the second.
We just have to know, like, we don't have to do anything to start it. So right away, remember, our one without the variable alone goes on the left. And the one with the one we're using goes on the right. So we know we can replace y with this by substituting. So we're going to get 2x, I'm going to draw a line so y'all know. 2x minus 3 times 2/3 x minus 6 equals negative 15. So what do we need to do first to solve for x? Distribute, right? And we're distributing a negative 3. So when I come in here, I know that y'all hate fractions, so can we do this in the calculator? What does it give me? So I get 2x minus 2x. What's negative 3 times negative 6? Positive 18 equals negative 15. Now what happens when I combine like terms? They zero out, and I end up getting 18 equals negative 15. Is that true or false? False. 18 does not equal negative 15. Therefore, what do you think your solution is? What kind of system is it when there's no solution? Inconsistent, because there's no solution. Now, this is hypothetical. Hypothetical. What if I did all that work and I got 18 equals 18? That's true. So what would my answer be? Infinitely many solutions. IMS, which means it would have been dependent and consistent. Okay. So remember, that's hypothetical. That's obviously not the answer to this one, but I just wanted to show you, because we don't do an example of that, that if you got down to this point where your letters canceled and it was true, it would be IMS, dependent and consistent. Now your favorite. What do you notice on the back?
Word problem.
Word problems, our favorite. What kind of answer do we give when we have word problems? Word answers, okay? Don't just box a bunch of numbers, because I'm going to take points off, because I'm asking a question and you have to answer that question with words, okay? So knowing that, it says City Park Golf Course charges $20 to rent golf clubs plus $55 per hour for golf cart rental. Sea Vista Golf Course charges $35 to rent golf clubs plus $45 per hour to rent a cart. For what number of hours is the cost of renting clubs and a cart the same for each course? So I just realized there's two unknowns here. That's what variables represent, right?
The number
Put
of
it away.
hours.
Okay. What did you say?
Number of hours.
The number of hours. What is our other unknown?
The cost.
Our total cost. That's exactly right. So we can use X and Y. We can use whatever we want. But what is our slope here? Because we have the E words each, every, per. So what's my X going to be?
55.
No. Words. It says per hour. So X is our number of hours. And what's Y going to be? Our total cost. So knowing that, we need to come up with two equations, one for each park. This first one says charges $20 to rent the golf club plus $55 per hour. So what do you think that's going to look like? Yes, so 55x, because we see the word per, we know that's telling us that x goes with 55, plus the $20 that we're only paying once because we only need to rent golf clubs once, right? Now, Sea Vista Golf Course charges $35 to rent clubs plus $45 per hour for the golf course. So $45 per hour plus the club rentals. Now, what do you notice here? Which one are we going to pick to plug in? Where's our variable that's alone? They both have one, so does it matter which one we pick? No, so if we just want to pick the first one, that's fine. So this is the one I'm picking, so I'm going to write that one second. And the one I didn't pick first. So if I know y equals 55x plus 20, I'm going to substitute in here 55x plus 20 equals 45x plus 35. And what do I do to solve for x? I always like to move my smallest x, so we're going to move 45x by subtracting 45x from both sides. 45 minus 45 is 0. What's 55x minus 45x? So I get 10x plus 20 equals 35. Now what? Minus 20 on both sides. I get 10x equals 15. Now what?
Divide by 10.
Divide by 10. And what does x equal?
15 divided by 10.
What's 15 divided by 10? 3 over 2. But do you ever ask anybody like, hey, what time? And they're like, oh, 3 over 2 hours. Like, would that be the answer? So what would it be as a decimal?
1.5.
And then x represents hours. So we know in 1.5 hours.
So then we'd write out in 1.5 hours you complete the same cost.
So here's my question. Does it ask what the cost is?
Or like how many hours it takes.
It just asks how long. So do we even need to find cost if I keep going?
No.
No, so we can say both are equal at 1.5 hours. Any questions with that? So let's look at the next one. It says the math club raised money for its summer trip by washing cars. They charged $3 for a car and $5 for a truck. Suppose the club earned a total of $181 for washing a total of 49 vehicles. Write a system of equations stating these facts and solve the system to find out how many of each kind of vehicle they washed. So what are my unknowns?
How many cars were washed for each?
For each what?
Like car and truck.
So we can use C equals the number of cars. We can use T equals the number of trucks. Now, does anybody have an idea of what my equations would be? Not quite.
180
So the way these work, these are going to be standard form equations, because right away we see there's not really like a starting point with a slope, right? Do y'all notice that? Okay. We kind of have two unknowns. So we always put money with money with money. See how those three numbers have dollar signs? So $3 for a car, so 3C, plus $5 per truck, 5T, equals a total of $181. So money goes with money goes with money. Huh? There will be. What's the other number we haven't used? The total of 49 vehicles. Well, what makes a total? You have to add them. Well, wouldn't it just be the number of cars plus the number of trucks? No money. We already made the money equation. So it's literally C plus T equals 49. Because C represents the number of cars plus the number of trucks, and it's a total of 49 vehicles. So does it make sense? Yes. So now which equation are we going to change?
Probably the smaller one.
The bottom one, right? Because we already have two letters that have the variables of 1, positive 1. So what do we want to do? We can literally just subtract T from both sides and get C equals 49 minus T. Would it have been okay if we did minus C on both sides? Yeah, it doesn't matter. They're both of positive 1 variable. So remember, the equation we changed goes second. And the equation we didn't touch goes first. So if C equals 49 minus T, I'm going to replace C with 49 minus T. So I get 3 49 minus T plus 5T equals 181. I'm going to distribute 3 times 49. Gives me 147. And 3 times negative T is just negative 3T. Bring down my 5T equals 181. Now what? Combine. What am I combining? Yeah, I'm combining this negative 3T plus 5T. And what does that give me?
2T.
Positive 2T. Bring down my 147 equals 181. Now what? Subtract 147 from both sides. And I get 2T equals 181 minus 147. 34. Last step. Divide by 2. And I get T equals what? So I know this means we washed 17 trucks. So our last step is to take this 17 and plug it in for T. So get C plus 17 equals 49. How do I solve for C? And C equals 32. And C represents cars. So we know our final answer is 17 trucks and 32 cars. If I just wrote 17 and 32, is that 100% right? you have to put words, because how do I know you didn't solve it wrong and you think 32 trucks and 17 cars? You have to use words because you were given word problems. Okay, if there's no words in your answer, something's wrong. Okay? So one thing I do want to say, so I want you to be clear that number 1 and number 2 are just setting them up. There's no actual solving.